When dawn breaks over the modern Tokyo skyline, the urban canopy is pierced by a bright orange and white lattice of steel. But in 1945, this exact footprint was an endless expanse of flattened ruins and rubble. The firebombings of World War II had left the capital virtually leveled. A decade later, the city was rapidly rebuilding, and television sets began appearing in living rooms. To feed this new medium, private broadcasting companies hastily erected their own transmission antennas across the city, cluttering the skyline and creating a chaotic web of signal interference. The Japanese government intervened with a simple solution: construct a single, centralized broadcasting beacon powerful enough to beam television and radio signals across the entire Kanto region. Planners designed this superstructure to function as a monument of national recovery. Its upward growth became a physical parallel to the rising economic confidence of a society redefining itself through technology. The government entrusted this monumental task to Tachu Naito, a structural engineer known today as the father of Japanese towers. Naito's mandate was physically daunting. He needed to design a structure taller than the Eiffel Tower, and he had to do it in one of the most seismically active zones on the planet. In the late 1950s, Japan was still operating under severe economic constraints. The high-quality structural steel required for a project of this magnitude was both expensive and in critically short supply. To bridge the gap, roughly a third of the required metal was sourced directly from the battlefields of the Korean War. Planners purchased damaged United States military tanks, melted down their heavy armor, and reformed it into the structural steel beams of the tower's base. Traditional high-rise construction workers, known as toby, took that recycled steel and assembled 4,000 tons of it almost entirely by hand. They completed the massive project in just 18 months. By literally melting down the heavy armor of a global conflict to forge a civilian communications tower, the builders physically embodied Japan's pacifist, forward-looking rebirth. Today, that bright red, angular steel framework stands in stark juxtaposition to the curving gray roofs of Zojoji Temple. That massive steel web is the result of Naito's core architectural philosophy. Instead of designing a rigid structure to stubbornly resist kinetic energy, he utilized a flexible lattice framework designed to absorb and dissipate it. When typhoons or magnitude 8 earthquakes strike, the top of the tower can flex and sway up to a full meter without sustaining structural damage. Tokyo Tower reaches 333 meters, edging past the Eiffel Tower by 9 meters. Updating the chart with structural weight reveals the efficiency of Naito's design. Tokyo Tower used roughly 4,000 tons of steel, compared to the Eiffel Tower's 7,300 tons. The striking international orange and white color scheme wasn't chosen for its aesthetics. It is a strict legal requirement mandated by Japanese aviation safety regulations for tall structures. This philosophy turned seismic vulnerability into a structural asset. By allowing the framework to flex under pressure, Naito established a template for survival in an environment defined by natural disaster. From the Foot-Town commercial complex at the base, visitors can physically engage with that engineering by ascending a 600-step open-air staircase up through the core of the steel framework. At 150 meters up, climbers encounter a cultural anomaly tucked into the main deck, the Tower Daijingu Shrine, officially the highest Shinto shrine in Tokyo's 23 wards. Stepping onto the observation decks, the intricate steel beams give way to a sweeping view of modern Tokyo, with a sprawling, hyper-dense urban canopy stretching out in every direction. Its central location and massive scale offer uninterrupted sightlines that extend past the dense skyline to the snow-capped peak of Mount Fuji. Reaching the summit transforms the visitor from an observer of a steel skeleton into a witness of the city's transformation. The view provides physical proof of a recovery that started with recycled tanks and ended with the sprawling metropolis below. For decades, the illuminated tower stood starkly against the night sky, acting as the undisputed focal point of the city's mid-century urban development. But in 2011, Tokyo faced a technological crisis. A mandatory nationwide switch to digital television broadcasting required high-frequency signals that the 333-meter tower was simply too short to transmit over the rising wall of new skyscrapers. To solve the interference, the colossal 634-meter Tokyo Skytree was erected across town in 2012, officially stripping Tokyo Tower of its primary utilitarian function. In Tokyo's aggressive urban redevelopment cycle, obsolete infrastructure usually faces a swift and predictable fate: demolition and replacement. Yet the public vehemently rejected any plans to tear the structure down. Over half a century, the tower had become deeply embedded in Japan's romantic identity, featuring prominently in countless anime, manga, and films. Losing its primary functional purpose actually saved the structure. It elevated Tokyo Tower from a piece of replaceable industrial infrastructure into an untouchable cultural monument. Today, the city maintains a deep emotional connection to the tower's landmark light. The illumination shifts with the seasons, glowing a cool, crisp white during the sweltering summer months and switching to a warm, comforting orange for the winter. For moments of national significance, the modern Diamond Veil lighting system takes over. The tower's 17 tiers of LEDs can blanket the structure in vibrant, multicolored illuminations to mark celebrations, mourn tragedies, or reflect cultural pride across the dark waters of Tokyo Bay. The Skytree handles the functional weight of the city's digital data, but the Tokyo Tower remains the permanent reference point for the city's romantic history and its collective memory of rebirth.